object. So some of that light comes into the telescope enclosure and we think just bounces around. So it hits the floor and the wall and the back of the telescope and kind of pings around and re-enters the optical path and then joins in the receiver going, I'm a bit late to the party, but here I am. And unfortunately, the mathematical techniques that are used to produce the spectrum, they kind of scramble this and tell you there's some other signal at another wavelength in there. And it kind of makes the spectrum undulate up and down. It's just like this huge, hideous, complicated wave pattern. So I've been sitting looking at the new JCMT data we got just this February going like, that's 50 waves, all of different sizes going past, you know. And I'm not the world's best surfer, but this kind of thing, you'd be like, yeah, these are all going past. And in the middle there is the tiny thing I'm trying to find.
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Good evening, everybody. Welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, not to mention the darn good friends of York University. I'll be one of your three hosts this evening. My name is Paul Delaney, and we're joined by, fresh from her gallivanting around in the woods, hi, Julie.
Hi.
And we have a newcomer to our midst tonight. We'll talk more about him in a moment, but hi, Quentin.
Hey.
There we go. Party of three to keep you company tonight. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. And of course, it is Monday night. It is therefore Science Night in Canada. The lineup is entirely Canadian, starting with ourselves, York Universe. On to Western Worlds, Quirks and Quarks, not to mention Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, that's Eastern Daylight Time, or Tuesday morning at this time of the year, that is 1 a.m. Universal Time, of course. The York Universe production works in concert with the online public viewing program run by the Observatory team. Hi there, team. It runs, of course, between the hours of 9 and 10 p.m. local Toronto time. By all means, please point your favorite web browser to observatory.info.yorku.ca and follow the links to OPV, online public viewing, and join the chat, join the conversation. Our broadcast is powered by and is in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you might have about past shows, or if you have suggestions for future topics, by all means, send us an email, observe@yorku.ca. You can always connect with us on Twitter, where our handle is @YorkObservatory, or on Instagram with the handle @YorkUobservatory, and Facebook @Allan Carswell Obs. Oh, such a mouthful, it really is. All of our programming, of course, is free. But if you would like to make a donation, see our website, observatory.info.yorku.ca, and by all means, press the big friendly donate button. We will be monitoring the chat room for questions and, of course, attempting to post commentary there as well. The current weather conditions outside, we needed the rain. There's lots of rain out there, so no live imaging. However, of course, there will be lots of archival imagery. So we've had lots of excitement amongst the team here. Julie, to begin with, you're fresh from your observing trek to Killarney Park. Rumor has it that you enjoyed yourself.
I did. I want to go back now. The city has too many people and not enough stars, and I want a telescope in my backyard. Thank you.
Have you mentioned this to Dennis recently?
Well, I mean, he was looking at the domes, and he was like, oh, we could have one of these in our backyard. And I was like, sure. But like, what are we going to look at?
Right. That is the problem, isn't it? That's for sure. So the skies were dark at Killarney. The weather was cooperative.
The weather was cooperative, clear sky every night, a few little clouds on the Friday when we were having our like nighttime observing session, but nothing that interfered with what we were doing. So that was good, especially considering we've had about 100 people come out.
Wow.
And then the very last night that we were there, Saturday night, was cloudy. And I would have loved to have one last chance to, try some astrophotography. But you can't have everything. I was at the scope like Tuesday, Wednesday, Thursday, and Friday night.
Very good. Very good. The southern Milky Way was nice and bright.
Milky Way every night. Saturn and Jupiter. The kids and my husband looked through the telescope and were like, "No way that you put a sticker on there." I was like, "Nope, you are looking at the thing." And so, the astronomy was awesome. The park is amazing. We made lots of snake and frog and butterfly and other types of animal friends. Saw a bear.
Oh, saw a bear. Wow.
Yeah.
Sounds so like exciting. You had, she sounded as if she had a good night. Good few nights.
Yeah. We, good hiking. If you like hiking, it's a good place to go.
So obviously going to Killarney is a good opportunity for both the environmental aspects of great scenery, great participatory activities, and then terrific astronomy in the evening, which of course is what the Killarney Park Astronomer in Residence program is all about, to be able to tell everybody, show everybody about the wonders of the night sky.
Absolutely. And everyone at the park is phenomenal. They're just lovely people. So
well, that helps too.
It does.
Okay, so you obviously are going to go back at some point, but obviously we've got another person on the line here, Quentin. Quentin, introduce yourself, and then rumor has it that you're heading for Killarney very soon too.
Yes, thank you, Paul. My name is Quentin Wayridge. I am a recent graduate from York University. I am a former student coordinator at the Allan Carswell Observatory, and I am the current outreach coordinator for the David Dunlap Observatory in Richmond Hill, with working with the Royal Astronomical Society of Canada. And yes, starting on September 19th and going to, I believe, the end of the season, so for 3 weeks, I am going to be taking Julie's place as the astronomer in residence at Killarney, and I couldn't be more excited about it. And listening to her description of it, I'm even more excited now. I'm basically vibrating with anticipation.
You give an observer the opportunity to go and see the sky under clear, dark conditions. Yeah, what's not to like, eh?
I'm really eager to be on the program tonight too. It's really great to have the opportunity to talk to you tonight and to be on.
Well, welcome to episode 503. So mark that on your calendar. You debuted on 503. But of course, you have been indirectly associated with York Universe through the OPV program for what, 3 years now?
Since 2008. No, sorry, 2018. No,
I was going to say, you're not that old, mate. Either that or my memory has failed terribly. But 4 years. So yes, you're quite familiar with our activity, so as to speak. But this is indeed your first opportunity to be heard live, so as to speak.
Yes, I believe so.
Well, welcome to the show. Julie and I will make sure you have a wonderful evening. And on that note, Julie, this week in space and astronomy history, take it away.
Okay. Yesterday was the anniversary of the big total solar eclipse. And it was one of the biggest internet events in recent history. I know that it was also a very big live event. But but it was one of the biggest internet events too, with the biggest online people, like, viewership that NASA has ever measured. More than 50 million people tuned in for the live broadcast at nasa.gov and on their like social media platforms, and almost 31 million unique views on their Facebook before and after the eclipse. People traveled all over from the United States. This was the one that was visible from coast to coast, basically, through the United States. And people traveled from all over to be in the path of totality on the 21st of August, 2017, 5 years ago. It doesn't feel like 5 years.
It does not. Okay, so where were we all on that particular day?
Well,
where were you?
That was the summer before I first came to York as a student. And I remember that eclipse. I remember I was disappointed because I didn't get my act together in time to get one of the safe observing the scopes
glasses
to observe it safely. Yeah.
Right.
So what I did was I waited for totality and I just kind of walked out on my porch and I didn't look up. I didn't look at the sun, but I just wanted to see if I could see the world around me just kind of getting darker. And I was not able to observe it, and I was kind of disappointed. And I was so tempted to look at the sun, but I didn't. I knew better, and I went back inside.
Well, of course, you weren't in the path of totality, were you?
No, I wasn't. That was
that was the snag. What about
deep down? I knew that it wasn't going to work, but I was just like kind of hoping.
Right. Well, you'll get your chance on April 8th of 2024 if you're in Southern Ontario. You can make amends at that point in time.
Absolutely. Thank you.
What about you, Julie? Were you in Aurora, in Toronto?
I was not. So we were traveling that summer. The purpose of the travel was not the eclipse. The purpose of the travel was the birth of my niece. And so we were not in the path of totality the day of the eclipse. We were in the path of totality the day after the eclipse.
That timing is reprehensible, but anyway, go on.
I know. But we did see it. We were in Glacier National Park in the States. We were on our way back from Victoria. So we saw it at 95%, which was awesome in and of itself because I had not seen a solar eclipse up until that point anyways. So any solar eclipse was awesome. It did, you know, at 95%, the world does get dark around you, which was cool. I got a few pictures because I did have the glasses and stuff, and I just held it in front of my camera lens. I had a bigger piece of protective stuff that I held in front of the camera lens, so I have a few pictures of it. It is a little ridiculous that I was in the path of totality the next day. I totally plan to be in the path of totality next year. I will totally, I'm taking that day off.
2024, right?
2024, sorry.
Yeah.
The year after next.
You can take a day off next year too.
I can. Okay. I won't see an eclipse if I do that next year.
No, it'll be your practice day.
Yeah. What can I say?
They're well worth observing to both of you. There's no question. On the 2017, my wife Lynn and I were bobbing around in the Caribbean on a ocean ship. We were doing a cruise at that point. It was only 80% as well, but we had like 1,500 pairs of glasses to hand out to the shipboard community, and they were absolutely wrapped in what they could see. Now, of course, they were enjoying themselves with a lot of libations, and there was lots of swimming going on and keeping cool, but putting all that together with an eclipse that got to 80%, they thought was really, really good. And I gave live commentary all throughout the partial phases. So it was memorable, but yeah, you've got to be able to find an opportunity for the 100% totality. It really is worth seeing. I've seen 3 of them. I've lived to tell the tale, and I strongly recommend anybody who's listening, not to mention my colleagues on the line here, find a way to get to totality, because it is really, really exciting.
Yes. Well, there will, my consolation was that, there will be other solar eclipses, but Niece's being born only happens once for that niece. So
quite true. Quite true. Good argument. For everybody, April 8th, 2024, it crosses the continent of North America again and passes basically through Niagara Falls and up through Montreal. Toronto will be at 99%, but anybody who's got friends in Hamilton, they will be camped on their grass, I have no doubt.
I got a friend in Hamilton.
There you go. I would take down the bottle of scotch early and claim your area. Okay, Quentin, would you like to take us out to the edge of the solar system, please?
I would be delighted to. So on August 24th of 1989 was the Voyager 2 flyby of Neptune. Voyager 2 was the only mission to visit all 4 gas giants. That's Jupiter, Saturn, Uranus, and Neptune. And it was originally only planned to go to Jupiter and Saturn, but further funding was awarded after its planned mission succeeded, and it was able to hit all 4 planets. So the course was changed toward Neptune, and off it went. And it reached the Neptune system, as I said, on August 24th, and it imaged a bunch of the moons. And back at this point, we only knew about 2 of Neptune's moons. We only knew about Triton and Nereid. And we found 6 more: Naiad, Thalassa, Proteus, Despina, Galatea, and Larissa. Neptune is, of course, the Roman god of the sea, and the moons are named after deities associated with the sea. It also studied the atmosphere, magnetic field, and other parameters, such as the mass, which allowed researchers to debunk the Planet X theory. The orbit was actually consistent with the new known mass of Neptune, meaning that there did not need to be an additional massive body out beyond the orbit to be responsible for its observed orbit. Voyager 2 remains the only mission to have visited Neptune, or Uranus for that matter, and it was very useful in confirming or clarifying a lot of our previous Earth observations.
That mission was really quite exceptional, and again, I'm going to show my age here. I was watching the flyby live. NASA TV was still in its infancy at that point in time, but they were broadcasting almost 24/7 the exploits of the close encounter. And to see Neptune live for the very first time with that level of detail, the big black spot and so on, clearly visible in the blue upper haze of Neptune, it was really very, very special. And if I can ever find a VHS machine that still works, I've got that recorded, but it's on a VHS tape.
I can help you out there, Paul.
I dare say you probably can. It's one of those things which, I keep near and dear to my heart in that regard. But one of these days, I'm just going to have to turn it digital or something. But yeah, it was really exciting. As you said, Quentin, it's the only probe that has managed to fly by all 4 of the Jovian worlds, all 4 of the gas giants. And we knew this was the last hurrah as far as Voyager 2 was concerned. Yes, it's still operating. Yes, it's continuing to give us data out beyond the heliopause and so on. But none of that data that is flowing back is, visual camera type stuff. Neptune was going to be the last hurrah in that regard for Neptune. For Voyager 2. And it really was something very special.
How exciting to get to see that live. That's incredible.
As I said, NASA TV was still in its infancy at that point in time, but they knew the value of this particular flyby. And the audience, I don't remember what the number was, but I'm sure it was very significant. York had a dish that was pointed towards the one of the few, at that point in time, transmitters from Earth orbit of NASA TV. And it was pumped to anybody who wanted it on campus. And there were quite a few of us who were tuning it in. But yeah, it was really good stuff. Okay, moving right along here, folks. I want to take us, well, in a way, further out, and in a way, not quite so further out. And special condolences to one of our hosts, Ariella, in this regard. Pluto, that beloved former ninth planet, fell from grace as far as the International Astronomical Union was concerned on the 24th of August, 2006.
Boo.
A moment's silence, please. Okay, so everybody remembers Pluto. It was that tiny little object that was found in 1930 by Clyde Tombaugh. And because Clyde was looking for planet number 9, when he found Pluto, obviously planet number 9 was a planet. So therefore Pluto was a planet. It was perfect logic, not a problem. We had never really defined what a planet had to be. What were the attributes associated with a planet? That just was not on the horizon. And so all through the 20th century, everybody referred to Pluto as planet number 9. It sounded really cool. But starting in the 1990s, we began to recognize that there were a lot of other fairly decent-sized objects out in the vicinity of Pluto. And in fact, as the 20th century had unfolded, Pluto's mass had continued to dwindle. We expected Pluto's mass to be, several times the mass of Earth. There was expectations that it would be, in fact, as big as 10 times the mass of the Earth. For no other reason than that sort of seemed like a good round number. But as the century unfolded and our ability to observe Pluto increased, so too did the mass of Pluto decrease. And it finally stabilized with the detection of its moon Charon in 1978. And of course, once you have two objects orbiting around a common center of mass, Kepler's third law kicks in, and voila, we are able to actually measure the mass of Pluto. And it came in to be, piddly. let's just call it that. It was really tiny, a fraction of the mass of the Earth, comparable in mass to that of our moon. And so Pluto was sort of like this dwindling object as the century unfolded. And then we started finding all these trans-Neptunian objects. And that made people, particularly in the astronomical community, want to define the parameters that represented a planet. If Pluto was a planet, what was to stop all these other trans-Neptunian objects being classified as a planet? And so there was this thought, maybe, just maybe, we didn't want to have 122 planets in our solar system. Maybe it needed to be a more exclusive club. So in the first half dozen years of the 21st century, the IAU struck a number of different committees to try and come up with a rationalization with respect to what we called a planet. To cut a very long and complicated story short, at the IAU's meeting in Prague in 2006, a vote was taken on the definition of a planet. And that definition basically says, A, you have to orbit the sun. Tick the box for Pluto. B, you have to be essentially round in what we call hydrostatic equilibrium. Tick the box. Pluto is basically round. The third criteria for a planet is that it has to be basically in charge of its own planetary orbit around the sun. It has to govern the activity of objects that are in that orbital space. Okay, cross that off for Pluto, because in fact Neptune governs Pluto's orbital path, and there are a large number of other trans-Neptunian objects that actually cross Pluto's orbital path. And so Pluto failed this third criteria. Pluto fell from the planetary club, and this is where everybody weeps piteously, and it becomes nothing more than another, but perhaps important, trans-Neptunian object. Sometimes it's referred to as a Plutonin, but it's a very unusual term. Pluto is a trans-Neptunian object. So bottom line to it is that Pluto no longer could be considered a member of the planetary entourage of our solar system. Has that discussion about that description of a planet, and Pluto in particular, ceased as a result of the 2006 vote? No. Here we are, 16 years later, and the debate continues to rage both in the public popular circles, because they loved Pluto as a planet, but even in astronomical terms, the criteria associated with what is a planet is still up for massive debate. And of course, we now know of about roughly 8,000 exoplanets, and the definition of a planet in our solar system is not viable with respect to exoplanets. You can't tell, for example, whether or not an exoplanet is round based upon our current observations. You can't tell whether or not it's governing all of the other objects in its orbital path around its parent star. So we have a definition that applies only, at the moment, realistically, to planets in our own solar system, objects in our own solar system. And so the debate continues. We have not heard the end of the discussion about what we classify as a planet. However, I would be very surprised if any new definition of a planet would allow Pluto back into the planetary club. At any rate, 24th of August, 2006, Pluto, the beloved object found in 1930 by Clyde Tombaugh, was no longer called a planet.
Very sad.
This is where I bring up the old Spike Jones IKEA commercial with the lamp.
Okay, you're gonna have to fill me in on this.
Okay. You see at the beginning a woman come out and she puts a lamp at the side of the road. She goes upstairs and she turns on a new lamp, and then it starts raining. And then the Swedish guy comes on and he says, "I bet you feel sorry for the lamp." "That's because you're crazy. It's just a lamp. Besides, the new lamp's better." I bet I bet you feel sorry for Pluto. "That's because you're crazy. It's just a rock. It doesn't care what we call it." People get so emotional.
It's a rock with a heart on it.
Sure. And you know what? I love Pluto. Pluto's awesome. It's adorable. It's a thing with a heart on it. But like,
it doesn't care what we call it.
So emotional over this. I'm like, you guys, people, like, things get reclassified in science all the time. No one's getting up in arms about like a frog that is now in a different genus than it was 5 years ago. Like, it's a little like it. Yes,
you raise an extremely good point.
Rant ended. But yeah, that's where I stand on it. I don't care what we call it. I just kind of like, it blows my mind that people get so like, oh my God.
In 2006, when the New Horizons spacecraft was launched towards then planet Pluto, it launched in January. The decision in Prague came down in August. There was a member of the US Congress, and I do not remember the honorable senator's name, but he basically asked NASA to reconsider doing what it was about to do, spend 9 years flying off to Pluto, and it was no longer a planet. Now, bear in mind, the spacecraft was already en route for 7 months, okay? So I'm not sure what he really wanted NASA to do. Just turn it off and call it a day? I mean, just because Pluto was no longer called a planet didn't mean it wasn't going to be an interesting object to go and visit. But the name, the label, seemed to be very important to this honourable member of Parliament.
I cannot tell you how often I've been asked, what happened to Pluto? Nothing happened to Pluto.
That's right. It's still there.
It's still there. It's still doing the same thing it was doing when I was a kid, when it had the label planet on it. It doesn't care. It has no feelings.
Okay. I think we have done this one to death. I think it's pretty clear what we think of the debate. Speaking of the Spitzer Space Telescope, Julie.
It does have a name. All right. August 25th, 2003, the Spitzer Space Telescope was launched. And actually, when it was launched, it was called the Space Infrared Telescope Facility. And it was renamed in December of 2003 in honor of astronomer Lyman Spitzer, who had promoted the concept of space telescopes in the 1940s. And this renaming happened after a contest. The Spitzer is the third space telescope dedicated to infrared astronomy, following IRAS that was in 83, and the ISO, which operated from 95 to 98. It was the first spacecraft to use an Earth-trailing orbit, which was later used by the Kepler mission. It had 3 instruments on board that included the infrared array camera, the IRAC, the infrared spectrograph, the IRS, and the multi-band imaging photometer for Spitzer, MIPS. That's just funny. It was originally
I like IRS actually, but anyway.
IRS is funny too, yeah. IRAC, IRS, and MIPS.
Rest to space.
It was originally planned as a 2.5-year mission, with the expectation that the mission could be extended to 5 or slightly more years until the onboard liquid helium supply ran out. The supply ran out on May 15th, 2009. So 2 of the 3 of those instruments on board could no longer be used because they couldn't be cooled. However, the 2 shortest wavelength modules in the IRAC camera could continue to operate, and there were a total of 4 modules in that camera. So they could continue to operate with the same sensitivity as before, and so the mission continued as the, quote, Spitzer warm mission. And so the operations actually continued until January 30th, 2020. And so some notable results. In 2005, it was the first telescope to directly capture light from exoplanets. These were hot Jupiters, HD 209458b and TRES 1b, although it didn't resolve that light into actual images, but it did capture it, which was a first. There was the discovery that Cohen Kui Tau 4 had a planetary disk that was vastly younger and contained less mass than previously theorized, leading to new understandings of how planets are formed. It discovered that the Milky Way has a more substantial bar structure across its core than previously recognized. An image of a quasar in the Draco constellation that was taken only to help calibrate the telescope was found to contain an infrared glow after the light of known objects was removed. And astronomers Alexander Kashlinsky and John Mather are convinced that the numerous blobs in this glow are the light of stars that formed as early as 100 million years after the Big Bang. And they are redshifted by cosmic expansion. There was involved in the discovery of the Double Helix Nebula, which is possible evidence of massive magnetic fields generated by the gas disk orbiting the supermassive black hole at our galaxy's center. It mapped the atmospheric temperature of HD 189733b, which was the first map of some kind of an extrasolar planet. It was used in the discovery of the Phoebe ring of Saturn, which is a large, tenuous disk of material extending from 128 to 207 times the radius of Saturn. And then there were the GLIMPS and MIPS-GAL surveys. GLIMPS, and this is totally a backronym, I'm sure, the Galactic Legacy Infrared Mid-Plane Survey Extraordinaire. And it was a series of surveys that spanned 360 degrees of the inner region of the Milky Way galaxy. And the MIPS-GAL was a similar survey that complements the GLIMPS surveys and covers 248 degrees of the galactic disk. And during the warm phase of the mission, Spitzer was used to prepare the way for the JWST by identifying targets for JWST, and was used to discover exoplanets via transit and gravitational lensing methods.
A busy telescope, whichever way you want to count it.
Absolutely.
It's 7. Go on.
Oh, I was just going to say, it's really interesting to me that while it was doing all of this extra solar observing, it just happened to discover another ring of Saturn. Like that's the item on this list that really sticks out to me.
Honestly,
true.
it stuck out to me too. I was like,
Yeah.
that's Saturn. Okay.
Well, I guess in part it was being inspired by the Cassini work. Cassini was in orbit around Saturn in this time frame, and to be able to get the bird's eye view, the larger view, Spitzer was tagged to be the spacecraft to do that. So it's a combination of being up close and personal, aka Cassini, with let's get the bigger view here, the whole orbital view, and that was done by Spitzer.
Yeah, I guess it really depends on what observing projects are being proposed by astronomers and what gets selected, right?
Yeah, I mean, the fact that Spitzer operated for 17 years, well and truly beyond its intended lifetime, and okay, so it's operating half of that time in warm mode, half of that time in cold mode. The fact that you can still get great science out of the spacecraft, even though it's not operating in its original specification, I think just goes to show how creative astronomers and engineers can get.
Absolutely.
Yeah, it's good stuff. I mean, spacecraft have got terrific longevity. We've spoken about that on many occasions on this show. There is no shortage of examples of spacecraft that were going to run for a few weeks, a few months, a few years, and then they go ahead and run for a few decades. And that's a good segue because, of course, you want to tell us a little bit about Voyager 1 now, Quentin.
Yes. So another milestone in the Voyager missions. On August 25th, 2012, Voyager 1 entered interstellar space. So Voyager 1 is, of course, the twin to Voyager 2, which we talked about earlier. But it was actually launched 16 days after Voyager 2. The mission was very similar. It was surveying the outer solar system and performing space studies. It visited Jupiter, Saturn, and it performed a close flyby of Titan, which is Saturn's largest moon and the largest moon in the entire solar system. Titan took priority over Pluto. After successfully completing the planetary science mission, Voyager 1 was further funded to study the distant solar system and interstellar space. So Voyager 1 overtook Pioneer 10 a few years later as the furthest man-made object in space, and it ran away with the title. It then exited the heliosphere on August 25th, 2012, when it passed into the heliopause, which is where theoretically the solar wind ends and the interstellar medium starts. Voyager 1 continues to travel away from Earth at about 17 kilometers per second, which is an absolutely astonishing speed. It would definitely make my commute to York very easy if I was Voyager 1. It is now about 157 AU away, astronomical units, but even still has not technically left the solar system. It is still approximately 300 years away from even reaching the theoretical Oort cloud and will take approximately 50,000 years to reach a similar distance to the closest stars. That is incredible.
Space is big, I guess, is the best answer I can give you to that.
Certainly.
But it is beyond the heliopause, beyond the heliosheaths, and so while it is gravitationally still bound to the sun, it is not beyond the reach. It is beyond the reach of the sun's immediate environment. That is to say, where the charged particle environment from the solar wind is the dominant environment that surrounds the spacecraft. It has passed beyond that and is in interstellar space.
I remember when I first learned about the Oort cloud in detail, I remember being very surprised by just how far out the sun's region of gravitational dominance extends. Because I remember reading about the solar system when I was a kid, I thought like Pluto was like the very outer limit of it. That like if you go beyond Pluto, then you're just in interstellar space. And there is so much of the solar system beyond that. It's crazy.
That's right. The third region or the third area volume of our solar system is much, much larger than the region in which our planets inhabit. We spoke briefly about trans-Neptunian objects, the Kuiper Belt, and so on. But all of those pale into insignificance when we start considering the Oort cloud and the distances involved. Yet the Oort cloud is bound gravitationally to our sun, not very strongly. It doesn't take much of a perturbation, a passing star, to swirl and kick material in the Oort cloud around, and including releasing some of it to truly interstellar space. But yes, gravitationally speaking, the sun's influence does reach out far further than its radiation environment.
Wow.
And just one very, very tiny correction, Titan is actually the second largest moon in our solar system. It is actually beaten out by Ganymede by about 20 odd kilometers, as I recall.
Oh, you're right. You're right.
Yeah. It's just a tiny little point.
They're both larger than Mercury, though. Isn't that right?
Oh, that's right. They're both of order 5,000 kilometers in diameter. So yes, much bigger than Mercury. So they are larger than planets, and here we go with the planet discussion. Titan and Ganymede, they don't orbit the sun. They orbit Saturn and Jupiter respectively. But while Titan was expected for the longest time to be the largest satellite, it was because of the atmosphere. The atmosphere, of course, swells its apparent size. But when we were able to get up close and personal to all these objects, the measurement of the physical diameter of the planetary surfaces, Ganymede wins out, but only just. Minor little point. I want to take us back in history here, and I want to bring us down to earth, so as to speak. There was this guy back in the early 17th century who was playing with glasses, little lenses, and his name was Hans Lippershey. He actually realized that if you had the right combination of convex lenses, you could actually bring distant objects a little closer to you. Now, whether Lippershey was really the first person who discovered the telescopic effect, it's not particularly clear. It's one of those sort of murky areas of history. But he is often credited with the original invention of, quote, telescopic optics. Except there is no indication that he utilized it for astronomical observation. And of course, like all good science discoveries, the military found good use for it because they could actually see their enemies coming from across the horizon and gave themselves lots of advanced notice of the incoming challenge associated with that invading army. Galileo, by contrast, heard about Hans Lippershey and the optics involved, put them together to make his own version of, quote, the telescope, although he didn't call it a telescope initially. He referred to it rather as and I have great difficulty pronouncing this, the perspicillium. And I'm sure that it's pronounced better than that at some point. But he used this device, and I'm going to say telescope because by 1611 he figured out that telescope was a better word for it anyway. He was able to systematically observe the night sky, make observations of things like Jupiter. He discovered the Galilean satellites, Io, Ganymede, Europa, Callisto. He recognized the rings of Saturn, although he didn't know what they were at that point in time. He referred to them as the ears of Saturn. But he systematically observed the night sky. And so we often refer to Galileo as the first person to use the telescope for astronomy. Whether or not he is indeed the first person who turned this collection of optics onto the night sky, he probably wasn't. But he is the first person who observed the night sky, recorded that information, and then published that information. And so he utilized the telescope for astronomical purposes without actually discovering the telescope or inventing the telescope per se. And it's even debatable whether or not Hans Lippershey actually should claim that fame. Bottom line to this is that the term telescope was utilized in 1611. In fact, it was coined by a mathematician by the name of Giovanni de Messinian. But Galileo, being something of a showman, because he was trying to make a point with respect to the use of the telescope, he actually took the telescope out into the public arena in 1609. Hence, on or about August 25th, 1609, Galileo introduced the telescope to the public. So you could arguably say he was, quote, the first person to utilize the telescope for public outreach. He actually got people to look through the telescope, the Galileo moment, if you will, for the first time, and see things in the night sky that they could not resolve with the naked eye. And so it's one of those, I think, fairly important moments in history, excuse me, where we utilized astronomical instrumentation, not straight out for science, but rather for the dissemination of knowledge, for the public outreach value that is often associated with all sorts of telescopic observations. So August 25, 1609, or thereabouts, Galileo marches the telescope out into the public arena.
So I've always found it fascinating, the initial impressions that Galileo had of the things he was seeing. You mentioned that he interpreted Saturn's rings as ears. Didn't he also at first believe that Jupiter's moons were attached to springs? Because he could see them appearing to like move back and forth?
Exactly. The four Galilean satellites are in the equatorial plane of Jupiter, and from our viewing perspective, it really does look like they're either beads on a string or, as you say, objects on springs. He couldn't see the springs, obviously, but he could see these little point masses moving backwards and forwards with periodic motion, as if it was objects on springs. But when you think about it, Quentin, back in the early part of the 17th century, what are you to make of it?
Yeah.
The idea even of gravity was still 40 or 50 years into the future with Newton. Galileo was making observations, seeing things move backwards and forwards, and the only realistic comparison he could draw on Earth was objects bouncing up and down on a spring.
Yeah, it's interesting. Like now, because we are so used to the way that planets work, we have this intuition for it. But all of that had to be developed, right?
That's exactly right. 1610, 1609, 1610, the brand new refracting telescope was now being utilized by a number of differing people, but what they were seeing was brand new. And so, yes, the vocabulary, the interpretation, and even at that point in history, the notion of physics was still a pretty brand new type of affair.
So because Galileo's famous for like being under house arrest for saying the sun is at the center of the solar system. Like, how do you intuit or deduce that the sun's at the center of the solar system and the Earth's going around it, but not that the moons are going around Jupiter and they must be on springs?
Well, remember, it's sequencing here. His first observations of Jupiter and Saturn in 1609, 1610 were just that, first observations, first impressions. Okay. I think it's fair to say that as time went by and he eventually wrote out the Starry Messenger, his interpretation of what he was seeing in the night sky had matured. By that
he figured it out eventually.
Yeah, well, I think that's right, exactly.
He was the smart guy.
Well, he was, and he was very, very dedicated. Determining that the moons of Jupiter were gravitationally bound to Jupiter, looking at the phases of Venus as it moved, quote, across the Earth's sky, aka around the sun, looking at all of the pockmarks on the lunar surface, so it wasn't a perfect sphere. Not so swift looking at sunspots with unfiltered optics. Yeah, that wasn't cool. But nonetheless, his continued set of observations that spanned the better part of 10 to 15 years certainly would have developed a great deal of maturity in its understanding and its interpretation. But as I said, he eventually went blind, and he and the Catholic Church didn't have a good time of it, house arrest, and so on and so forth. He led an interesting life, I think we can easily say.
I mean, they apologized 400 years later.
Yes, exactly. Better late than never, eh? Yes, I think Galileo was right in 1992, says the Catholic Church. Okay, fine. Folks, you're listening to York Universe, the weekly broadcast of astronomy and astrophysics out of the Allan I. Carswell Observatory. Quinton, Julie, myself, keeping you company this Monday evening. Of course, it is Science Night in Canada. More about that later on. A reminder that this coming Wednesday, of course, the Allan I. Carswell Observatory has its Teletube Wednesday affair, where live imagery from the 1 meter telescope, weather permitting, may actually occur. Failing that, archival imagery, and of course, the observatory team delivering to you some interesting aspects of astronomy, and of course answering your questions on YouTube. So that's this Wednesday evening, 7:30 in the evening, if you can tune it in. Right, Julie, I think you want to take us into space.
I do. And in particular, an Indigenous woman is going to space. The first, which is cool. Her name is Nicole Onapu Mann, and she'll be making history as the first Indigenous woman to fly to space this fall as a NASA astronaut. She is enrolled in the Wailaki of the Round Valley Indian tribes in Northern California, and she'll be on board the SpaceX Crew 5 mission to go to the International Space Station that's set to launch no earlier than September 29th. She's going to be the mission commander on the SpaceX Dragon, and so is leading all phases of the flight from launch to re-entering the Earth's atmosphere at the end of her time, serving as part of Expedition 68. And during her time on the ISS, she will be a flight engineer. There are 3 other astronauts that will be on that flight. NASA astronaut Josh Casada, JAXA astronaut Koichi Wakata, and Roscosmos astronaut Anna Kikina. The crew will conduct about 250 experiments during their 6-month stay on ISS, including this really cool thing, the biofabrication facility, which is literally 3D printing human cells with the long-term hopes of eventually printing human organs, which is awesome. She hopes to do a spacewalk because she's done a lot of training in the buoyancy tank and she finds it really cool. Mann is a colonel in the U.S. Marine Corps. She holds bachelor's and master's degrees in mechanical engineering. She is also a fighter pilot and a test pilot and has served combat missions in Afghanistan and Iraq. She was chosen as one of the 6,100 applicants to the 21st class of NASA astronauts with 7 others in 2013. In 2020, it was announced that Mann would be part of the initial 18-member Artemis team, so she hopes to be selected to go to the moon as part of the Artemis missions. And in case you're wondering what other Indigenous folks have been involved in NASA missions, the first Indigenous man to go to space was John Harrington, and he is Chickasaw. And then there is Aaron Yazzie, who is Diné, and he's a mechanical engineer at JPL, and he's contributed to 4 Mars projects.
Wow.
Quite the collection.
I mean, that's a very small number of Indigenous people. I don't know if there's more, but the article that I was reading mentioned those 3. But she's quite accomplished, and go you. I hope she gets to go walk on the moon.
She certainly is. You don't become a colonel in the Marine Corps because you're a slacker.
No.
No argument about that. Certainly the Crew Dragon missions have allowed for a good expansion of the number of NASA astronauts to go to the International Space Station, and NASA has been making, I think, increased efforts to try and broaden its ethnicity, if I can use that term in this regard, making sure that the characteristics of the new astronaut classes are more in keeping with, shall I say, the larger population in the US. And so I think this is a really good step in the right direction. As you say, Julie, though, well and truly overdue. So as a consequence, I mean, we're talking about 21 classes of NASA astronauts, and the first 5, 6, or 7, I can't remember what the number is, were all entirely male. It wasn't until the class of 78 that Sally Ride and company, women, actually made the cut. So, yeah, we've got a lot of time to make up for, shall we say, in terms of Indigenous people as well as women astronauts.
Absolutely.
So she ticks off 2 bases in that regard, which is good. It's also exciting that we're talking about the Artemis cruise. And as I will talk about in just a moment, next Monday, Artemis 1 is scheduled to fly. If all goes well, by Artemis 3 in 2025 or 2026, depending on how badly the timeline slips, we will be talking about 4 people returning to lunar orbit and 2 people returning to the moon's surface. And if all goes well, a more regular number of visitors to the lunar surface in the later part of the 2020s. Well and truly overdue for this conversation, but gosh, to think that we could be seeing all sorts of men and women from multiple countries on the surface of the moon for the equivalent of a lunar colony by the end of the current decade, to me is extremely exciting.
There's so much exciting stuff going on right now. I really want to know what happens with that biofabrication facility. I'll be watching the news for that. That's really interesting.
Yeah. Imagine being able to print organs. First of all, you wouldn't need donors, so you could just have organs when you need them. And if you could print them so that they wouldn't get, like, you wouldn't have to worry about the drugs that people have to take to avoid, like, rejection of organs, that could be a total game changer.
Really? Yeah.
I wonder why it has to happen in 0G.
Things go wonky when you try to do it on Earth.
Really?
Because gravity. Yeah.
Gravity's a pain. Well,
gravity
okay.
is a pain. Microgravity works better for this sort of thing, apparently.
Fair enough. Okay, all right. Let me just move on here to give a quick little summary of Artemis 1. As you know, there's a lot of hype that is now flying around the place. Artemis 1 is due for launch, if all goes well, August 29th, around about 8:30 in the morning Eastern Time. So this, of course, is the moon rocket. This is finally NASA putting together the revamped plans for the Saturn V. This is the new space launch system, and Artemis 1 will be an uncrewed launch to the moon. This has been a long time coming, just to catch you up. Yeah, the last time we were in lunar orbit with a human-rated spacecraft was Apollo 17. Yes, I saw the launch. And that was December of 1972. Yeah, count it, 50 years ago. Were we asleep at the switch? Oh, don't even start me. At any rate, finally, Artemis 1 is now back at the launch pad and is preparing to launch next Monday. As I said, it's an uncrewed mission. The aim of the exercise here is a full-up test of the Space Launch System. So that's the rocket propulsion system, the Orion capsule, going to the moon, orbiting the moon, coming back to the Earth as fast as we did with Apollo. Therefore, the fastest re-entry in 50 years, testing the heat shield, and so on and so forth. A full-up dress rehearsal of what the mission with people will look like 2 years from now. So this is a really exciting step. You may recall that earlier this year, they had the full wet dress rehearsal for the Artemis system. That was basically where they fueled up the entire vehicle and did a countdown to within around about 90 seconds of ignition. aborted obviously, made sure that all of the computer integration, all of the electronic integration was working well, gave all of the flight controllers a little bit of a run through, because again, we haven't done this for 50 years. And all that eventually sorted itself out. They had a few issues, but now, as I said, the Artemis 1 is back on the launch pad, and if all goes well, 8:30 next Monday morning, we will see it launch to the moon. It will be about a 30 to 40 day mission if they launch on time. They obviously have backup windows stretching through September, but the mission should run for 30 to 40 days overall. So a few days in Earth orbit, a few days transiting to the moon, a couple of weeks in lunar orbit, testing out all of the systems, and then coming back. So 30 to 40 days, all should be very exciting. If this goes well, then that clears the way for the Artemis 2 mission, which will be approximately 2 years from now, and that will take a crew of 4 back to the moon for the first time since, as I said, 1972 and Apollo 17. Those 4 crew members will include 1 Canadian. We have 4 active Canadian astronauts on the roster, and so I dare say they're all getting really excited. My money is on Jeremy Hansen being selected to fly to the moon in 2024. And so whichever way you want to cut it, this is truly history in the making.
On our website. Really easy to find us. We are astronomy.fm. You may also find us in the iTunes radio.
Definitely, as I say, a long time coming. So yeah, make sure you're up next Monday morning, bright and early. If you're on the GO train, Julie, make sure you're tuned into some sort of internet broadcast.
Oh, I will be.
Folks, we're at the top of the hour. Thank you very much for joining us. This has been York Universe, the weekly broadcast of astronomy and astrophysics out of the Allan I. Carswell Observatory. Quinton, Julie, myself, Paul, keeping you company this evening. Of course, we have still great stuff coming along. We've got Western Worlds, Quirks and Quarks, and Science for the People. It is, after all, sort of science night in Canada here on astronomy.fm. Everybody will be back next week. Remember, Teletube on Wednesday. For me, good night.
Good night.